Hello everyone. This is a problem which involves the equilibrium of certain rigid bodies under the action of various forces. So, two uniform identical rods of same mass, uniform identical rods, that means the linear mass density will be same. So, for all calculation purposes, we will take the center of mass of the rod at its midpoint. So the two uniform identical rods of same mass are tied together with the help of a string and balanced as shown in the figure. So the system is in equilibrium and there are two rods inclined at 37 degree with the horizontal, and at the top you can see the two ends of the two rods are tied together. Uh, the minimum coefficient of friction for which the system will remain in equilibrium in this position is 2 by x. Then we have to find the value of x. In such problems, you should always proceed with the free body diagram. And since the two rods are identical, you can proceed by investigating any one of the rods. So we have the diagram here. Let us enlarge it a bit. So let us talk about the rod on the left. The forces acting are there will be a tension force in the string at the top. Its weight will be acting at the center of the rod. Let us say the mass of the rod is m. Mass is not given, but for calculation purpose we will take the mass as m. So mg will be acting through the midpoint of the rod. There will be a normal reaction where the rod is making a contact with the ground, and since the rod is in equilibrium, if you only concentrate on the rod's equilibrium, since tension force is acting towards right, the friction force provided by the floor on the rod at its contact will be acting towards left like this, and this friction force must be limiting because we have to find the minimum coefficient of friction. So for equilibrium condition, since we have to find the minimum coefficient of friction, so for friction to be maximum we must take the limiting value of the friction, and so this will be equal to mu times n. So we will proceed by translational equilibrium as well as rotational equilibrium. For translational equilibrium, we must have normal reaction equal to mg. Also, the friction force should be equal to mu times n, and for if we take for horizontal forces, these are for, this one is for vertical equilibrium. This is vertical equilibrium. Friction equal to mu n, ये तो वैल्यू ही हो गया. And for horizontal equilibrium, we must have T should be equal to friction or T should be equal to mu times n. So this equation comes from horizontal equilibrium. So let us say this is equation number 1 and this one is equation number 2. And for rotational equilibrium, we will apply torque equation about this point. Let us call this point as O. So since equilibrium is there, the torque about the point O, sum total of all the torques about the point O must be equal to 0. And let us say this length is L by 2. So this will also be L by 2. And this angle will be alternate angle 37 degree. So if we write the torque equation about the point O, the torque of tension about the point O will be clockwise, and the torque of mg about O will be anti-clockwise. And because the net torque is 0, that these two torques must cancel each other. So the torque of tension will be T into this perpendicular distance. This will be the perpendicular distance. And this distance can be easily written as L times sine 37 degree. So we have T into L sine 37 degree, and this must be balanced by the torque due to the weight mg, and the distance of mg, perpendicular distance of mg from O, can be written as L by 2 cos 37 degree. So the torque of mg will be equal to mg into L by 2 cos 37 degree. So L will get cancelled on both sides. T into sine 37 degree, we know it is 3 by 5. This will be mg by 2. Cos 37 degree, we know it will be 4 by 5. This 5 and 5 on both sides will get cancelled. And so we have T equal to 2 by 3 mg. And if we put these values here on the left hand side, so 2 by 3 mg, we have put the value of T in equation 2 on the left hand side, must be equal to mu times normal reaction. We have calculated from equation 1, it is mg. Mg will get cancelled on both hand side, and so mu will be equal to 2 by 3. Now in the problem it is given that the value of mu is 2 by x. So if we compare this value with 2 by x equal to 2 by 3, we directly get the value of x as 3. So this is the answer. So this is a simple problem involving equilibrium, translational equilibrium as well as rotational equilibrium. Translational equilibrium, we have written vertical equilibrium. We have got one equation from there, n equal to mg, and for horizontal equilibrium we have another equation from where we got T equal to mu1. And then we wrote the equation for rotational equilibrium, from where we got the value of mu 2 by 3, and on comparison we got the value of x as 3. So that is it. I hope you get it. Thank you very much.